Welcome to School of PE podcast. I'm your host, Chris Miller, and I'm so glad that you could join me this week. We are going to discuss topics about FE, PE, and SC, and we're also going to answer questions that will help students prepare for their exams. Let's get started. Hello, and welcome back to another exciting episode of the SOPE podcast. I have a special guest with me here today, Mr. Doug Smith from HoloPundits. He is the Customer Success Manager for HoloPundits, and he is going to talk to us about AR and VR technology and engineering, education, and whatever else he wants to talk about. So let's give Mr. Doug Smith a warm welcome. Doug, great to see you today.
Thanks, Chris. Hey, happy to be here. Excited to chit-chat with you a little bit about the technology and engineering.
Yeah, I'm excited. All the episodes I've been doing so far, I've had the pleasures of, speaking to some different engineers about some different topics. So I'm excited today. AR, VR kind of gets the motor running, So,
well, you're in the right place.
Yeah. I mean, if you could do me a favor and maybe, because AR and VR is still pretty new to a lot of people. So not everyone understands the technology or even knows what AR, VR is. So if you could maybe give me a little bit of a brief history on this technology to catch our audience up to speed.
No problem. You're in for a treat. I actually brought some widgets and gadgets with me today to show you guys. So AR, VR, we'll break that down step by step. The technology itself has been around for, a few decades actually, but I can remember actually in high school I went to Cedar Point, which is an amusement park here in Ohio, and they had this really cool new thing. It was a roller coaster virtual reality, and you put on this headset and it was strapped, to a wall monitor or whatever, and you got to go and pretend you were on a roller coaster. Now, incidentally, there were real roller coasters right behind me, so I went over there and did that. But that was when I was first introduced, and that was like around the year 2000. So you can kind of get a sense of how long this technology's been around. And it's really, really, really improved since then, from that Cedar Point virtual reality headset roller coaster scene to today. It's just nuts. If you have not experienced virtual reality, augmented reality, or mixed reality, I definitely recommend it, even just to test it, just to see what's out there and experience it. So what we have here next to me is a virtual reality headset. Virtual reality is where you put on a headset. You don't see anything in your real world environment. You're only looking at what's in the headset itself. And that becomes an animated, immersive reality environment. You have hand controllers that go along with that you could, manipulate objects and things like that. We'll talk about later. The mixed reality came out with Microsoft. This is a HoloLens, is what we call it. It's a Microsoft product. And you wear it, and it's actually glass. You can't see that in the screen probably, but I can actually see my real world environment, everything that's in front of me. But then the glass actually portrays holograms and holographic images over my real world environment. So it's a really cool way, especially in engineering. We see a lot of use cases with the HoloLens, which we can get into here in a bit. And then augmented reality hit the stage with the public back with Pokemon Go a few years back. If you might remember that, you probably got into the craze. You take your iPhone or your Android and you install the app, and you'd be able to see through your camera your real world environment and overlay animations, 3D models, images. In this case, you got Pikachu and all those little fun critters with the Pokemon Go. So those are the three different reality and immersive technology, and together we call that extended reality. So that's what I pretend to be, as an extended reality expert. But really, I'm just really trying to help folks figure out the best use cases with the technology in their space. So hopefully that was a good overview for you.
That's a great overview, and it kind of, what I remember from your whole overview is the idea of a virtual roller coaster. That is the only way you're getting me on a coaster.
Are you scared of?
Oh man, I am. I remember when I was a kid. I grew up in California. Knott's Berry Farm was a popular theme park or amusement park to go to, and I remember going there with my brother and my parents. And Montezuma's Revenge was this coaster that just started off at zero and just took off, went up, went back down. And I remember standing in line with my parents, my brother, for like an hour and a half. It finally our turn. I get in, I get right out. I told my dad, and I said, "Hey, I'll stand here and hold the camera." So,
so you didn't even try it?
No. Oh, no.
Oh my gosh. Well, we're going to have to take a trip to Cedar Point or Kings Island or something here in Ohio.
Sounds good. I'll gladly stand and hold the camera or the VR lens. But, also maybe you can kind of shed some light on this. A lot of times when you hear about AR, VR technology, you think it's just gaming. That's all it is, or at least that's what the perception was. Maybe it's changed a little bit, but can you talk about some of the other areas that you've seen a big use or a big need for this kind of technology?
Yeah, absolutely. And you're right. That conception is true. It actually started out virtual reality as gaming. PlayStation, came out with their virtual reality headset. Facebook came out with the Oculus, which is this bad boy here. They came out with the early version, I don't know, 5-6 years ago. And it was really targeted at the consumer gaming industry. But then people like engineers and people like educators, they got into this technology. They realized there are so many uses for this technology, and especially when you can have the immersive feel and the environment that looks so real. You could do virtually anything in this environment. So I see a lot of customers and clients that have needs in engineering, which I think is why we're talking here a lot today. A lot of manufacturing, a lot of training and education. The company I work with, we launched an education module for sciences, so science teachers can use this in the classroom with their students to help explain those really complex topics that I have no idea what they are, but boy, I can see it and feel it, engage with it, and now I understand it. So those are the main use cases we're seeing with all these technologies right now.
That's great. So whenever something new pops up, whether it be a technology or maybe a new baseball bat for you to hit those big long dingers with, there's always that assumption that, is it a flash in the pan or is it here to stay? So let me ask you this. So AR, VR, flash in the pan or is it here to stay?
Well, you're asking the wrong guy. I'm biased on that, of course. I think it's here to stay. But, the numbers, they speak for themselves. Right? We have a lot of research out there, especially because of COVID. When COVID hit, we have all these companies, enterprise corporations, we have manufacturing, we have pharmaceuticals, we have, just any industry vertical you can think of is now accelerating their adoption of this technology. Where it was a thing that they were considering and thinking about conceptually, you're going to see how the market plays out, see how the technology advances for their specific causes. We're now seeing those same people who were 7 or 8 years away from adopting this technology. They're using it today. This is a real thing. The U.S. military just bought $21 billion of the HoloLens mixed reality technology, both headsets and software development. That's a 5-year plan. So, to say that you're on the front end of something that's a flash in the pan, or that's something that's not going to be here a couple years from now, totally inaccurate at this point. The numbers speak for themselves. The adoption is here. It's real. It's staying. The market has followed. There are so many startups happening because of the development needs that are out there. If you're talking about engineering and folks in your world, every single company that I've talked to, every single industry that I've talked to uses engineers. And those engineers are using models. And those models right now are CAD files or they're Revit files or whatever. And they need a way to both manipulate those files in a real hands-on way and share those files with their customers or with other engineers or whoever, where they can get in a collaborative environment. And there is no better way to do that than popping on a headset or popping on a HoloLens and being able to see what the other person is seeing and manipulate with each other the models that you're looking at in that engineering environment. So I think it's here to stay, and I think you're going to see a lot more adoption, especially in the engineering world as we move on.
Well, that sounds great. So, for School of PE, we've dabbled a little bit in the AR, VR, is actually in one of the books we actually used, some AR, VR in our PE Civil Breath book. And earlier you touched upon how this technology can help you better understand some of those more complex topics that, when you look at it just on paper or in a book, you're like, okay, I get it, but I don't get it. Being able to see it maybe makes it a little bit easier to grasp or understand. So you were talking about like models. So are you saying that, let's say, let's kind of take a step maybe from engineering. Let's say, you're in an anatomy class and you're trying to better understand like the digestive system or one of the other systems. How do you see AR helping with that?
Yeah, I wish I had it in this technology when I was going through high school and middle school, because I'm a very visual person. I'm a hands-on learner. Instead of being in customer service as I am, I might be a scientist. Had I had this technology back then, but I see that struggle with teachers trying to get those points across to the students. I've been working with teachers with this technology for the past year or so, and it really is that wall, that hurdle where you have different styles of learning in a classroom, right? You have 30 kids in a class, you have 30 different styles of learning, and they can be broken down into a few different categories. You got your audio learners, your visual learners, your hands-on learners as well. And really what VR and AR does, it actually tricks the brain. So it gets you to a point where you're combining those learning styles all in one experience, right? So, and that's what you want. You want to not just go audio, you're not just visual, not just hands-on, but you want all those together, because that way every learner is included in this learning style. And that's exactly what virtual reality does. That's exactly what augmented reality does. It tricks the brain to build those stimuli. You want to build those associations with what you're learning to recall later. And the research is out. I mean, it's out there. It proves that the increase of exam points, the increase of building those associations, the increase of learning motivation itself, which is a fabulous thing, because you want to get kids excited about school and excited about learning. But that's really what we focused on with one of our products out in the schools called XR Guru, is really focusing on those science topics. And because that's the low-hanging fruit for making something visual. They're complex topics. You can get into a cell in virtual reality and look at the different components of a cell structure. You can look at a human anatomy. You can get in there and take a look at the digestive system. My wife was having some issues with her back a few weeks back, and I said, well, listen, hop on the headset, get in there, and see, what is the nerve or what is the muscle that's hurting. And she did. She got in there and she was looking at the human anatomy in the virtual reality environment, and she was able to pinpoint exactly what was happening. And she found some stretches to do for that particular muscle, and it was incredible. Like, if people just knew, and that's, when I work with teachers, I say, let me send you a headset. Let me show you what this is like if you've never experienced it, because that will make all the difference. Absolutely.
Wow. Well, doctors better watch out. Self-diagnosis through a virtual lens, gives new meaning to the virtual appointments.
That's right.
Trying to get back to engineering a little bit. Do you see any of the benefits that the world of engineering can reap through this XR technology? Yeah,
actually, my background's in construction and engineering, and even though I'm not an engineer myself or can even swing a hammer, I know that world. And working with engineers and architects, this technology really was attractive to me coming from that world. Not only do you have with what's called the HoloLens remote assist, where you can pop on a headset, you can be out in the field, let's say at a construction site or whatever your engineering is, you're at the site and you pop on one of these and you want to show other experts and other engineers, and maybe the customer who's at a remote location, you want to show them what that looks like in real time in the real world environment. Well, you pop on this and you have a hands-free, I've got my headset on. I can't put the real headset on or else it'll fall, but if I weren't wearing my microphone, I could show you what that looks like. And you can actually show and share the screen with the people that you wanted to share that experience with. And then the step further is if they have notes that they want to share, if they have 3D models of an HVAC system. Let's say you're at a show. You just built a shell of a building, and you're walking through doing a site visit on the shell of the building. You pop on the headset, and then somebody who's working remote pops up an HVAC system from a CAD file, and all of a sudden you can take that CAD file and you can move it 5 inches down, or 2 feet to the other side of the room, or wherever you want. And so that's one very specific use case in engineering, in the construction industry especially, where you can use this technology to really help you with streamlining your communication and figuring out what the design plans are going to look like before you actually get into construction, or before you get into a certain phase of construction. So that's one. I'd be happy to get into others too.
Yeah, I mean, training's a great point that you bring up. Sometimes, whether it's like, let's say you go to a construction site and you're maybe evaluating a site or an equipment, and you have someone in the field, and they might not be the expert that is needed for that particular task. Instead of having to bring out another expert, you're telling me that you could put on the lens and he could be looking at whatever it is, and someone could be, whether it's at home office back in LA or New York or whatever, and that expert can chime in and see exactly what that person in the field is seeing.
That's right. Yeah, and then they can overlay other models onto that environment as well using mixed reality.
That's pretty cool. That helps save some money. For flying out 2 experts. But also, let me ask you this. Let's stick with construction here. It's a dangerous, could be a dangerous thing, right? Construction sites. So do you see this technology being something that could maybe help reduce some of the workplace dangers?
Yeah, absolutely. So the best places for something like virtual reality, where we build a simulated environment of either a dangerous setup like construction or mining or electrical or whatever it is, or there's another way where virtual reality training comes in really handy, and that's repetitive processes. So let's say you're in manufacturing, for example, and you have an engineering process or a manufacturing process, and let's say you're a process engineer, and you want to really streamline that process to onboard and train employees in a very rapid way and a very consistent way. Well, you can build that all in virtual reality before you ever get them in front of a physical, actual machine, because those trainings can be expensive, especially if somebody makes a mistake on the machine and you have to pause the whole lineup and start all over. In manufacturing, in construction, it's the same way. You have dangerous environments. You have a lot of people who need to be trained in those environments. Don't put them out in the field right away. Step one, put them in a virtual environment, right? And those are things you can analyze. Those are things you can track their progress. You can give assessments and things like that in the virtual reality environment. So absolutely, yeah, that's a really growing use case that we're seeing, is the training in virtual reality. I'm working with a customer right now who's doing a training actually in HoloLens, which is the mixed reality, and that's where they're taking a product called Microsoft Guides, and they can actually build their own processes. And again, this is a manufacturing customer that I'm working with, and I'm working with the engineers in that manufacturing plant to figure out what is the process, taking their standard operating processes and putting them into a virtual overlaid environment in a giant warehouse, where this recognizes where you are, and you can and actually pops up the holograms and holographic animations according to where you're standing in that physical space. And then there are guides that allow you to prevent any sort of potential injury or walking into a piece of equipment that you don't want to step on or walk into or something like that. So a lot of really neat and dynamic tools that are out there, especially for engineers.
Yeah, no, that's a great point. Like, whenever, any company, whether it be engineering or any kind of, industry, actually, you bring in people to take on a new, job or task or whatever it is. It's not just the training as the sense that, you have someone, you're paying someone to train them and things like that, but it's also maybe the risk or cost of the machine that you're training them on. Some of those, as you mentioned, the machines that you're going to be working on are millions of dollars. So if you put some rookie on there and they make a mistake, and all of a sudden, bam, machine's done. You lose production, plus you lost the machine. So you're saying that you could put that process or that simulation in one of those lenses?
Yeah, absolutely. Yeah, and that's the exact scenario that you're talking about. Is these machines are so expensive. If somebody presses the wrong button, it just curtails the whole process. You got to shut down for 8 hours. Just the consumption of time and bringing resources in from elsewhere. One of the customers I'm working with one of these virtual trainings, they have to fly. They only have one expert who handles all the machinery and all the equipment. So he's in Chicago, and they've got manufacturing places all across the country, right? They have one in Atlanta, one in New Jersey, one in California. So if the machine goes down, they have to stop the entire operation at that facility, fly the person in from Chicago, and that person has to come and fix it. With this, first of all, you can prevent all the issues because you can train the people in that virtual reality environment. And second, if for some reason, Doug Smith gets on there, presses the wrong button, and the whole system goes down at that location, the expert doesn't need to fly in from Chicago. He can pop on HoloLens, and now he can be there remotely and see exactly what's going on, what the issues are, and troubleshoot it from that HoloLens environment.
That's pretty cool. So with any new technology, there's always, I guess you're going to say, maybe hiccups or limitations to implementing these technologies. So, can you talk to us a little bit about some of those limitations that, you see or that exist in implementing these type of technologies?
Yeah, sure. The real limitation is people don't know what it is. They know kind of conceptually, like, hey, yeah, virtual reality is cool. I wear a headset, I get in there, play around, maybe shoot some paintball guns at my friends, but you're talking about business use cases and industry use cases and engineering. It's really trying to get engineers, when I'm talking to engineers especially, trying to get them to be creative enough to understand what they can do with this technology. So I'm working with one engineer currently who's civil, and talking about focusing on their specialty, which is bridge repair and structural replacement. So trying to get them to say, okay, they have these inventories of bridges, right, that they have to inspect for the state. And so they go around the state and they have, 10,000 bridges that they have to inspect every year, and they go around, and so they're thinking a very analog way. They've got their pad and their pencil, and they're checking off the boxes and all this, and trying to get them to realize that in a HoloLens environment, you don't need a pad and a pen. You pop this on, and every single bridge that you go to, you stand in front of that bridge, and now all of a sudden this HoloLens is going to recognize that specific bridge, and it's going to remember the site visit from a year ago, and it's going to remember the data points from a year ago, and then it's going to be able to analyze that bridge and say, oh, well, gosh, this structure moved 2 inches from last year. So now we build that into an assessment based on the API and the databases that exist on that civil engineer's backend. But the HoloLens itself is a computer sitting on your head. So anything your computer can do, this thing can do. And you have the added bonus, it can recognize things, it can think, it can interact, it can engage in that kind of augmented reality environment. So getting the engineer, finally that light bulb came on, it's like, wow, this can do all that? And like, yeah. And now you have the opposite problem, but once the creative juices start flowing, you have the engineer thinking, well, I want to do all of this and this and this and this and this, and that's great, but we really need to narrow the scope. So it's really trying to figure out what the technology, the hiccups are, getting from not doing anything with it to doing too much all at once, going from 0 to 100 all at once. But what you really want to do is step into it phase by phase, and get used to it and get your people used to it and stuff like that. So that's what I've seen with people adopting this and some of the hiccups along the way.
Sure, seems like baby steps is the way to go.
Yeah,
instead of diving head first. That makes sense. So we've been chatting here for, I don't know, maybe close to half an hour, and one thing that's been kind of just sitting in the back of the head, and I just can't seem to forget is, and I'll kind of lay it out there before I go back to this, but new technology, all I'm thinking is like, holy cow, this has got to be astronomically priced. And then here I am thinking about that $21 billion that you mentioned earlier earlier in the chat here. And I'm like, holy cow. So, I mean, it's hard to pinpoint the cost, but like, how expensive is this technology to implement?
Yeah, that's a great question. And I get that question all the time from customers that I'm talking to or having kind of overview discovery calls with. And I like to be honest with folks, I don't like to hide things or what have you, but I think the mentality is with this technology, it's going to cost hundreds of thousands of dollars to build an experience or build an environment, or have a company like ours develop that. But that's not the case. Maybe years ago when this first started, there weren't a lot of programmers, there were not a lot of developers who could do this technology in an efficient way. But over the years, that's changed, and the market's become a lot more competitive, with the service side, which would be developing applications, developing software, 3D models, and things like that, and also the hardware side. So you have a lot of different companies getting in the game. Lenovo's in the game, HTC's in the game, and Microsoft's in the game. Apple's coming in the game very soon. So you have all these hardware devices coming out, and of course, in our market, it kind of drives the cost down. So even today, when headsets were thousands of dollars years ago, we're talking about this puppy right here, which is one of the better ones on the market. In my opinion, it's one of the best. This is the Oculus Quest 2. This is $300 out the door.
Oh, wow.
So that's not expensive at all. Any company can afford $300 for virtual reality. HoloLens, the mixed reality, are a little more expensive because there's not as many players in the market, and it can do a lot more, especially when you're talking about dynamic integration with back-end, databases and KPIs and things like that. So the headset itself is about $4,000 out the door for a HoloLens. So, but when you're talking to Fortune 500 companies and billion-dollar industry, that's nothing. $4,000 is nothing. Even engineers who can prove an ROI very, very quickly with a HoloLens, $4,000 is nothing just to get the headset. Now, when you're talking about developing different applications or different models or things like that, we're not talking hundreds and hundreds of $1,000s to enter the market. You're talking about a few $1,000s. A beginner's package to get kind of proof of concept, whether it's virtual reality or the mixed reality or augmented reality. You're really talking about somewhere in the ballpark of $5,000 to $10,000 just to enter and get kind of a proof of concept. Obviously, if you want to get really intense, like the military is going to do with that $21 billion, they're going. I'm guessing. I don't know this, but I'm guessing they're going to simulate actual battle experiences. And they're going to simulate actual, for the engineers, they're going to simulate combat conditions, and you have to build a bridge in this kind of environment, and you have to build an escape route for vehicles in this kind of environment. I'm kind of envisioning that, and you get really, really pricey really quickly with that, because you're talking about a lot of variables and a lot of development time and a lot of just security aspects that are going to just build that cost out. So you can get pretty crazy with it, but the average company that I'm working with, you're talking about $10,000, $20,000 on the higher end for an application for a really solid use. That, by the way, creates an ROI very, very quickly.
Oh, that's the important thing, right? But actually, that's not bad. I mean, that's not a bad price point. Just kind of as you were mentioning here, the whole thing with the military purchasing, spending a lot of money on this training, or not training, but on these sets. I mean, I can see how you brought up simulating battle scenarios, but not only does it allow people to, I guess, experiment or experience various type of scenarios they might run into in combat, but it saves lives. I mean, the training, but also when it comes to engineering, I can see this being used in like fire protection. When they're building and designing sprinkler systems for different types of commercial industries. So a lot of ideas that are just coming in through the head. So I mean, I could just see these people who are watching this podcast and they're just starting to drool at the mouth. Like endless possibilities. So let me throw this out there for you, Doug. So what would it take or what would it require for a company like you or a VR related company that, let's say I come to you and say, I design pilot seats for airplanes. And every time a new pilot joins, I gotta, not only gotta learn about the instruments and controls, but they gotta figure out how to use this seat. And the owner manual is 500 pages. Nobody in the right mind wants to read 500 pages. So if I came to you and said, hey, Doug, what can you do to help me better train my pilots to adjust these pilot seats?
Yeah, that's a great use case that I've actually seen firsthand with one of our customers. And there are a couple different things you could do. You could do in any one of these three technologies. It just depends what your end product is, what you want your results to be, what kind of ROI you're trying to do, what kind of training the pilots already have done on this seat that you're working with. But you could do something as simple as an augmented reality scan with the pilot's cell phone or an iPad. So they could scan either a code or an image on the seat itself and say, okay, this and the phone will actually recognize what seat that is based on the scan, and that specific manual will pop up for that specific seat, and maybe an instructional video, maybe a model will pop up of that seat where they can actually see the animated version of that model in real space using their device, and see how to operate it, see how to fix it, and see how to shift it around, and see how to get the seat warmer turned on and all that. But I don't know, do they have that in airplanes? I'm not sure. I would think those pilots get it made, but I don't know. So they're way up there, it gets cold up there. So, but that's kind of the simple version. That's kind of step one. Step two might be something in the virtual reality environment where you have a specific simulation of the cockpit and the seat, or wherever the seat is located in the plane. And then step three might be, and this is the actual use case that I've seen in a cockpit, where a pilot will pop on a HoloLens. The HoloLens will recognize the seat just from a spatial, kind of recognition standpoint, and it'll scan it, and then it'll pop up the seat in a holographic animation, and it'll show you all the bells and whistles of what the seat can do, and you can select and go through kind of the manual of what you need to do to work with that seat and what's needed. So those are kind of the general themes of what you could do there. How detailed or how simple you make that is completely up to you, but that's kind of my job, right? I get to talk with the customer and see what is it you're actually trying to do, right? What are you trying to accomplish? What's the work product you want, right? And so what are the KPIs with that? And those are the conversations I have. And a lot of times those are many conversations over a period of weeks, and they bring in different people as part of their team, which is all part of the conversation, right? And you figure that out, and finally, at the end of the day, you chisel out a scope of work, and you say, okay, this is the project, and this is what it's going to look like, this is what it's going to feel like. My team will actually build storyboards and go through, so visually the customer can kind of see before we ever start developing or programming, and we'll get to see kind of on the same page, literally on the same page, what the project will look like.
It's interesting. So I thank you for sharing that. One last thing I wanted to cover with you. So I've had the pleasure to work with HoloPundits. School of PE actually reached out to HoloPundits to create TAR codes for their FE Civil book and their PE Civil exam review guide for the breath. So can you kind of talk a little bit about the process of making TAR codes, but also, it's great to put these cool looking things in a book for people to scan, but the bottom line is, are they useful and are they helpful? So can you kind of tell me what you think the benefits of providing information in this format is? I mean, maybe not when it comes to engineering, but I'm sure you've worked with, other people in the education world, and we've talked about a little bit how AR, VR can help simplify some of the educational topics. So can you kind of explain the process of TAR codes, but also what are the benefits of sharing information in that way?
Yeah, absolutely. That's a great point, because TAR codes, that came from a product that our company actually developed called Total AR, which is a platform. It's one of the only ones out there where you as an individual or you as a publisher or what have you can actually create and manage your own augmented reality content. So we wanted to put augmented reality in the hands of anyone who is interested. And so that's where Totally AR came in. And so when we started working with you, we wanted to figure out, well, who's your end user, right? And that's going to be the student. They're going to be in the textbook. They're going to be, learning all this information. But then you have the added issue of, the tests change, right? From year to year, you might have completely different testing metrics, and so you have to reprint those books, or maybe there's a different way to go about it. So the cool part about Totally AR is that you can actually change the tar codes and use the same tar codes, but change the content that's connected with the tar codes. So tar codes, think of QR codes, right? And they're just a scannable image that you can scan with your mobile device. And once you scan it, it recognizes it and connects you to augmented reality content. So in this case, we're working with you guys to share, models of, civil structures. I know we've done the steel structure with the different points on the bridge, where students can kind of play with that in an augmented reality environment in their real space. I know, we can change the content. So you have a video of Chris Miller who pops up and tells you all about, whatever engineering you need to know for this year. Well, the criteria change, or we get sick of looking at Chris Miller for this video. So we want to put somebody else in there. We want to put some different information in there. And with Totally AR and the back end platform, you can actually do that. You can change the content. You can make the content dynamic. You can add more content on top of whatever's already there. And I think the benefit there goes back to what we talked about with the education and really learning in a visual way, in a hands-on way, where you're trying to understand those complex topics a little more easily. And so that's what we want to do with textbooks, obviously, in education. But you could do interesting things in other publishing worlds too. You got storybooks, for example. Let's say it's a kids magazine or something. National Geographic for kids. You could pop in some really cool scannable tar codes that pop up these really neat, interactive, engaging augmented reality experiences. So that's really what we want to do with that, and that's been pretty successful. We hope you guys have seen some success with it.
Absolutely.
And and more importantly, that your students will engage and be able to learn those topics a little more easily.
Absolutely. So, the tar codes have been a great thing for us that you guys have developed. I mentioned we put them in our 2 big books. Also, what we've started doing is integrating them into our question booklets. So, you buy a question booklet, it has a solution written out step by step. Great, right? But sometimes people still don't understand how to solve the problem, even though they're seeing the solution, because they're not seeing anyone work it out. So what we did is, utilizing the tar codes, somebody will scan the tar code. It'll actually play a recording of an instructor solving that problem. So that way, not only do you have it out in front of you, step by step, you're actually seeing someone solve it. So we've gotten some great use out of the tar codes, and we think that a lot of our students have been able to benefit from that as well. Doug, it's been, today's been a blast, talking about AR, VR. It's a truly a limitless spectrum that you can talk for hours about. I appreciate you coming out here and sharing a lot with our audience today. And I'd love to have you back.
Anytime. Yeah, absolutely. Maybe we'll get the little dirt board going next time. Do a little competition.
Let's do it. But hey, Doug, I appreciate it. To the rest of you guys, stay tuned till the next episode. Everyone have a great day, and we'll talk to you guys soon. See you later.